Going to be starting off with the March 2013 paper. Okay, if you turn on the inside page, you're going to see some equations. What I want you to do is to just pause this video and see if you can, if you know by yourself what the units for each thing is. And I'm going to go through them. So pause the video, see if you can write down what the units are. Now what you should have written is that wave speed is measured in meters per second, frequency is measured in hertz, wavelength is measured in meters. It's the same as the one below, where wave speed is measured in meters per second, distance is in meters, and time is in seconds. Electric power, if you highlight the W, that will remind you that it's in watts. Current is measured in amps, and potential difference in volts. Now the equation below that, the cost of electricity one, this is the tricky equation because it doesn't follow the normal rule. The cost of electricity is measured in pence, the power is measured in kilowatts, and the time is measured in hours. It's the only time where power is measured in kilowatts and time is measured in hours. And the cost of 1 kilowatt is whatever the cost is per kilowatt hour. Now back to the one below that, the power equation. Power, you highlight the W. Power is measured in watts. Energy, all energy, doesn't matter what type of energy it is going to be measured in joules, and time taken is measured in seconds. Efficiency is the useful energy divided by the total energy. Now you must remember that it's always going to be the small number divided by the big number. If you've got it the other way around, you've done it wrong straight away. It's going to be the small number divided by the big number, and then you're going to multiply that by 100. Notice the brackets. So you do this bit first, then you multiply it by 100. Now what I'm going to suggest that you guys do is get used to writing these facts down. The fact that 1 kilowatt is equal to 1,000 watts. 1 amp has 1,000 milliamps. An hour has 3,600 seconds. And 1 minute has 60 seconds, because then you can see how to convert between the two easily. So if you look at this equation here, the electrical power one, the electrical power needs to be in watts. So if they give you something in kilowatts, to get it into the watts, you will need to have a look. What do you need to do? Times it by 1,000. Right, and if they give you something in milliamps, but you need it in amps, because remember current must be measured. If we go back, where's current? There it is. Current must be measured in, as we said earlier, amps. So if they give you it in milliamps, and they could do, what you're going to do is you're going to go from there to there. You're going to divide by 1,000. Can you see you're going smaller? So if they give you something in milliamps, you need to divide it by 1,000 to get it to amps. Similarly, 1 hour to seconds, or seconds to hours. You can do that. So if you're going from seconds to hours, which you need to do in the cost equation, then you need to divide whatever time you have in seconds by 3,600 to give it to you in hours. And if you want to go from hours to seconds, so that's speed equals distance divided by time, which is not even on there, but it's wave speed equals distance divided by time, and you need it in seconds and they give it you in hours, then all you have to do is multiply by 3,600 to give you that. Finally, to get from minutes to seconds, all you need to do, 1 minute equals 60 seconds. So in order to get from minutes to seconds, you need to multiply whatever minutes you have by 60. Right, so just have a quick look at this question, pause the video, have a look, try and answer the question. Now with this question here, what you need to realize is that the converging lens and a convex lens is the same thing. So it's a lens that has like a stomach, if you like, so it's kind of bulging, right? And to give you some information about these lenses, number one is what it does is it causes the rays to join and causes a real image. Now, a real image is something that can be formed on a screen. Can you see this is the actual object? This is the image that it's made. It's a real image because we can capture it on a piece of paper. The other thing you need to know about convex lens is it causes the image to be upside down in comparison to the real object. So that image that the light rays have come through here, refracted and focused onto the paper and formed a real image. Now the distance x is called the focal length. And where the image forms is called the focal point. So the place at which the image is formed is called the focal point. And the place where the distance between the lens and the image is called the focal distance. Does that make sense? So looking at this question, let's have a look. Right, so I'm going to give you a few seconds, pause the video, and have a go at the question just below this one. So one of the things that you need to know is that the real image that is formed on the screen is always smaller than the actual, smaller than the distant object. Okay, so it's always smaller, and because we can capture it on a screen, it's called a real image. Okay, now a virtual image, this one here, this is going to be formed by a mirror. So a mirror causes a virtual image. Diverging, because this is a converging lens, a diverging rays of light would be caused by a concave lens. Okay, that would cause the rays of light to diverge, and that's it. I've decided this is how I'm going to do it. I'm going to flip over the page, tell you to answer the questions, then I'm going to do some writing, and then you can compare your answers to mine, and anything that comes up that you didn't know, write it on your paper. It's just easier that way. Writing and holding the phone is a bit hard. So here's the question. Have a go. Okay, so this is what you should have drawn. Ignore the red crossed out line because that was just me not reading the question. However, so that's lesson number 1, always read the question. However, if you look at the top line, what happens is the light is going straight and then it refracts, which means bends, and then it goes all the way down and it refracts and it keeps going down. So it's changed speed and direction because of refraction. So just to cover refraction again, refraction is when light changes speed and direction because it goes through something that is more dense. So the glass is more dense, so it's going to slow down the light and it's going to refract the light towards the normal line. So the angle, the refracted angle is going to be smaller. And as it's coming out of this lens, it's going to bend away from the normal line and the light is going to speed up because the air is less dense than the glass. I don't know what that is on my paper. So then we've got this equation at the bottom, which is really, there's kind of a trick to it, but it's not too much of a trick. If you look here, the time is in seconds, so we're happy. And if you look here, initially, when you look at the speed of light, it says 300,000 kilometers per second. And you might be thinking, well, shouldn't speed be in meters per second? And yes, it should be. However, if you look at the units within the answer, they put it as kilometers. Therefore, you can just leave it as kilometers per second and use the equation distance equals speed times time. Now notice, because there's rearranging, they give it to you, so you're not expected to rearrange. But you are expected to spot that because it's kilometers per second, that you just leave the kilometers per second and you're not changing it to meters per second. Anyway, so distance equals speed times time. You put your numbers in, that's kilometers per second times your 1.3 seconds, and that'll give you your answer, whatever that is. I'm going to let you guys use a calculator. You can do that. Right, so radio waves, they carry energy and information, so the answer to that one is D. So have a look at the next page, pause the video, answer the questions, then play the video. Right, so I'm still on this page and I thought that I'll just go through some extra electromagnetic spectrum stuff. So the way to remember this is raging Martians invaded Venus using X-ray guns. So each one of those stands for radio waves, microwaves, infrared. I'll let you read that. Radio waves are the longest wavelength and they have the shortest frequency. Okay, whereas gamma rays have a short wavelength but a high frequency, so their wavelengths are really close together, so there's going to be more waves per second passing a point, which is the definition of frequency, so it's going to have a high frequency. And then the other two things that you need to be aware of for P1 is infrared. Infrared radiation, which is part of the electromagnetic spectrum, was discovered by a guy called Herschel. and he used a prism to split white light into the colors of the rainbow. So that's red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, violet. And when he split this into those colors, he tested using a thermometer each color of light, and what he found was that as it went from violet to red, the thermometer showed an increasingly warm temperature. The temperature increased. So he put it just past infrared where he couldn't see anything, but the thermometer reading went up. So what that demonstrated to him is that there is something beyond red called infrared, and therefore it's something that's real, it's something that exists. And he discovered infrared because it caused a temperature change even though he couldn't see it. The next one is ultraviolet. Now this was done by Ritter, and he used white silver chloride powder. Now when you put white silver chloride into light, it begins to get black, so it turns black. So what he did the same. He split the colors of white light into the colors of the rainbow, and he started from red, went all the way down to violet, and he found that as it went from red to violet, the silver chloride turned black quicker. Then he put it just past ultraviolet, he put it just past violet, and he saw that it went even quicker still. Therefore, he discovered ultraviolet. Okay, so I'm going to turn over to the other page now. Okay, so looking from the top, what we can see these different types of energy. So I'm just going to go through some of them that you might not know where they can be found. So chemical energy can be found in batteries, food, and fuel. So that's oil, petrol, diesel, etc. Elastic potential is anything that can be stretched. It will have a store of elastic potential energy. Kinetic energy is basically anything that's moving will have kinetic energy. Electrical is obviously electrical, and I thought all the others were quite obvious, so I kind of let them go. Now the sun has nuclear power, and nuclear power stations have nuclear power. So looking at this, this is the device. So what you're using, the energy is transferred from, and what it's transferred into. So an electrical motor, it starts off as electrical, transferred to electric. A bow and arrow, as you're stretching it, it's going to cause elastic potential, and as you let it go, it's going to form or transfer into kinetic energy. Electrical kettle starts off as electrical, it's going to use it mostly as heat. Microphone goes from sound to electrical. Now these are all the types of energy that you need to know for your GCSE P1. And the way to learn it is most kids hate learning GCSE energy names. M stands for magnetic, kinetic, heat, light, gravitational potential energy, chemical sound, elastic potential energy, electrical energy, and nuclear energy. Okay, so that's how to remember that. So the question to part 2 is that in the electrical motor, some of the energy electrical is transferred into kinetic. What's happened to the rest? And the answer is it's lost as heat. Because obviously the motor gets hot, it's going to start getting hot, and you're going to lose that remaining energy as heat. So now we are on page 7. I'm going to give you guys a moment to do what you can, then we'll work with it together.